Learning mathematics through activities not only promotes interest in the subject, it also helps visualize abstraction with ease. Dear students, today we are going to perform an activity to factorize a given quadratic polynomial. To do this activity, we need some material, squared piece of paper of dimension 10 by 10 units. We need some rectangular strips of dimension 10 by 1 units. We need unit squares of dimension 1 by 1 unit, and we need a colored pen and a colored sheet. So students, let's start this activity. To factorize a given quadratic polynomial, we will take any given quadratic polynomial, say x square plus 7x plus 12. To factorize this, we will take the squared piece of paper. Let this squared piece of paper represent x square with dimensions x by x units. We need x, each rectangular strip here represents x with dimension x by 1 unit, and we need unit squares. Each unit square represents 1 by 1 dimension it has, and it represents a 1 unit square area. So, we have x square here. With this x square, we will have 7 times x. So, we will have 7 rectangular strips and we will have 12 unit square. We will arrange this material in such a way that we are able to obtain a rectangle. So, let us start the factorization of x square plus 7x plus 12. We will split the middle term 7x into two parts, say 3x and 4x, and we will arrange them adjacent to x square in such a way that no gap is left between these rectangular strips. So, let us start doing that. I am arranging 3 rectangular strips here. Remember, there should be no gap between the rectangular strips, and I am arranging 4 rectangular strips here. Again, there should be no gap between the rectangular strips. So, students, as you can see, I have x square plus 3x plus 4x, or in other words, I can say x square plus 7x. This remaining gap can be filled with the unit squares that we have. So, let us start doing that. We will fill this remaining gap with the unit squares. We have already arranged some unit squares. As you can see, this gap is getting filled. Remember, again, there should be no gap between these unit squares. Now, we have arranged these 12 unit squares here, and what do we observe? We get a big rectangle. Let us see what are the dimensions of this rectangle. The dimensions of this rectangle are x plus 3, x plus 4, x plus 3, x plus 4. That means this rectangle has dimensions x plus 3, x plus 4, or in other words, we can say that x square plus 7x plus 12 can be factorized into x plus 3 and x plus 4. Students, let us try and factorize the same polynomial algebraically. So, x square plus 7x can be split into 3x plus 4x plus 12. The first two terms, as you can see, in the first two terms x is common and in the last two terms 4 is common. Thus, we get the factors of the given polynomial x square plus 7x plus 12 as x plus 4 and x plus 3. Thus, the factors of the given polynomial x square plus 7x plus 12 are x plus 4 and x plus 3. These are also the sides of the given rectangle. Students, in this activity, we had taken a quadratic polynomial wherein the coefficients of x square, x and x to the power 0 all were positive. What if one or more of these coefficients is negative? So students, let's perform the same activity on one of such polynomials. We will again take the same material, a squared piece of paper and some rectangular strips. So let's factorize x square minus 7x plus 12. Students, as you can see that in this polynomial, the second term has a negative coefficient. So let's start factorizing this polynomial x square minus 7x plus 12. To factorize this polynomial, we will first take a squared piece of paper. This squared piece of paper again represents x square with dimensions x by x unit. As you can see in this polynomial, we have to subtract x 7 times from x square. Let's start doing that. We will take the first x, we will subtract it and we will do the same 3 times. So I have subtracted 3x from x square. Now I have to subtract another 4x. So let me try and do that. Oh, what do I observe? I cannot subtract another x from this x square because one complete x is not available to me. I will make it available to me using these unit squares. I will place these unit squares here, and as you can see, a complete x is now available to me. I can subtract this x from x square. I will do the same for the remaining 3x available to me. I will first place unit squares so that complete x length is available to me, and I will keep on subtracting the same. We have subtracted 3x and now we will subtract the last x from x square. So students, as you can see, we have subtracted from x square 3x and 4x. In other words, we can say that this figure represents x square minus 7x plus 12. Why plus 12? Because in order to subtract x from it, I had to add 12 unit squares. So students, this rectangle now has the area x square minus 7x plus 12. This remaining rectangle here, which has not been covered, again has the same area x square minus 7x plus 12, but the dimensions of this rectangle are x minus 3 and x minus 4. So students, what do we observe? We obtain a rectangle which is uncovered and the dimensions of this rectangle are x minus 3 and x minus 4. Students, let's try and verify our factorization algebraically. I have the polynomial x square minus 7x plus 12. I will split 7x into negative 3x, negative 4x. In the first two terms, I have x common, and in the next two terms, I have negative 4 common. Thus, we have factorized x square minus 7x plus 12 as x minus 3 into x minus 4. These are also the sides of the given rectangle here, x minus 3 and x minus 4. Students, you can perform the same activity on any other quadratic polynomial.